progression so that some problems that involve progressions don't impede you. Okay. So now we are going to talk of a sequence of numbers we are going to talk of a sequence of numbers, say A1, A2, A3, A4, AN, etc. A sequence of numbers of this kind, A1, A2, A3, AN. The manner in which this sequence is represented, this is a collection of numbers, A1, A2, A3, AN. The manner in which this collection of numbers is represented is like this. This is a sequence represented in curly braces like this. Curly braces AR means numbers like A1, A2, A3. R is like a running variable. R equal to 1, R equal to 2, R equal to 3, and so on and so forth, right? This is a sequence AR. So when someone says a sequence AR, it means a set of numbers like A1, A2, A3, AN, and so on and so forth, right? Now, if the sequence, so this R equal to 1 will give me the first term of the sequence, R equal to 2 will give me the second term of the sequence, and we have some term called AR in the sequence, which could be any term. AR is a floating term. AR is a floating term which represents all members of this sequence, right? AR, when it floats, it could be A1, it could be A2, it could be A3, and so on and so forth. So, if these numbers are referred to as some AR. The generic way these numbers are looked upon is AR. Now, if they have a property, if this collection of numbers has a property, any term minus the previous term is a constant. Suppose this collection of numbers has this property. Any term minus previous term is a constant. That means A2 minus A1, any term minus previous term is the same as A3 minus A2, any term minus previous term is the same as A4 minus A3, is the same as some AN. The term prior to AN is going to be AN minus 1, AN minus 1. If this is a constant, say D, if this is a constant D, then this sequence is referred to as an arithmetic progression. Then this sequence AR is referred to as an arithmetic progression. Or AP. Arithmetic progression or AP. And this constant D is called the common difference of the AP. This constant D is referred to as the common difference of the AP. This D is called the common difference of the AP. This D can be a positive number or it can be a negative number, right? Now, any term means the generic term of this collection of numbers is AR. The term prior to AR is going to be what? AR minus 1 would be the term prior to AR. So now any term minus previous term, AR minus 1, that's equal to a constant D for this collection of numbers. And that means this difference would be independent of R. That means whether you take A2 minus A1 or you take A3 minus A2 or you take A4 minus A3. It will not depend on R. This difference would be independent of R. Yes or no? It will be independent of R. Then this sequence is referred to as an arithmetic progression with common difference D. Now, if D is positive, then do you realize AR minus 1 will be positive? Right? AR minus 1 will be positive. If D is positive, that means AR will be bigger than AR minus 1. AR will be bigger than AR minus 1. That means any term will be bigger than the previous term. That means any term will be bigger than the previous term. That means A2 will be bigger than A1. A3 will be bigger than A2. A4 will be bigger than A3, and so on so forth. That means this set of numbers increases in value. It's an increasing sequence. It's then an increasing sequence. If D is positive, it's an increasing sequence. This is an increase. Oh, I hope all of you understand this. Right? In contrast, if D is less than 0, if D is less than 0, that means this right hand side, the common difference is less than 0, then AR minus AR minus 1, AR minus AR minus 1 will be less than 0, since the right hand side, the common difference is less than 0. Less than 0, or AR will be less than AR minus 1. It then would be a decreasing sequence, because any term will be less than the previous term. Any term would be less than the previous term. That means A2 will be less than A1, A3 will be less than A2, A4 will be less than A3, and so on and so forth. So as you keep moving rightwards in the sequence, the numbers decrease in value, right? So AR then is referred to as a decreasing sequence. Decreasing. This means decreasing sequence. Yes or no? Right? So if D is a positive numbers, then the sequence increases in value. If D is a negative number, sequence decreases in value. If D is 0 as a special case, that means if this is 0, then any term minus previous term will be 0. That means any term will be equal to previous term. That means A2 will be equal to A1, equal to A3, equal to A4. Then you get a collection of identical numbers. If D is 0, you get a collection of identical numbers. Yes or no? Yes. Right? So that's only a special case. D equal to 0 is just a collection of identical numbers. Theoretically, it's an AP, but practically, we don't look upon that as an AP. Right? Arithmetic progression. Now, so on so forth. This is fine with all of you, right? Now, that means, since any term minus previous term is D, that means any term AR can be looked upon as previous term plus D. Any term could be looked upon as previous term plus D. Right? So, if you add D to this A1, you get A2. If you add D to A2, you get A3. If you add D to A3, you get A4. And so on and so forth. Yes or no? Right? Now, think of it. 3 consecutive members of the sequence. Say AR minus 1, AR, and AR plus 1. Look at, these are 3 consecutive members of the sequence. These are 3 consecutive members of the sequence, and they will subscribe to this property. Any term minus previous term is a constant, right? That means AR minus AR minus 1 will be equal to AR plus 1 minus AR. for 3 consecutive terms, right? This will give me AR minus 1 equals AR equals AR minus 1 plus AR plus 1 by 2, which is the arithmetic mean of AR minus 1 and AR plus 1. Is this not the arithmetic mean? Arithmetic means what? Average, just the average of these numbers, right? So if you take 3 consecutive members of an arithmetic progression, then any term and then the middle term would be the average of the 2 neighboring terms, would be the arithmetic mean of the 2 neighboring terms. If you took 3 consecutive members of an arithmetic progression, then the middle term will be the arithmetic mean of the 2 neighboring terms. So if ABC are 3 consecutive members, if ABC are 3 consecutive members of an arithmetic progression, consecutive, they have to be consecutive. If they are consecutive members of an arithmetic progression, then B must be the average of A and C, the arithmetic mean of A and C. Right? Now, say I have a set of numbers AR in AP, in arithmetic progression with common difference D. Common difference means any term minus previous term. Any term minus previous term. If D is greater than 0, the progression increases in value. If D is less than 0, the progression decreases in value. Clear? If D is equal to 0, you have a set of identical terms. Clear? Now, look at this AR. It's a set of numbers A1, A2, A3, and so on and so forth. This is called the first term of the sequence. This is called the first term of the sequence. A1. Let me, in common terminology, let me refer to that as A. A1 is some number A. First term. Then, what would be the second term? You have to add D to the previous term. You have to add D to the previous term. So, second term would be A1 plus D, which is like A plus D. The third term would be A plus 2D. Fourth term would be fifth term would be A plus 4 minus 5 minus 1 into D. This is fourth term is A plus 4 minus 1 into D. Third term is A plus 3 minus 1 into D. Second term is A plus 2 minus 1 into D. Yes or no? Second term is A plus 2 minus 1 into D, where A is the first term, D is the common difference. Third term is A plus 3 minus 1 into D. Fourth term is A plus 4 minus 1 into D. Fifth term is A plus 5 minus 1 into D. The rth term in general, is A plus R minus 1 into D. That's the rth term of the sequence. First term plus R minus 1 into D. So if someone said find the 20th term, that's going to be A plus 19D and so on and so forth. Yes or no? So this gives me the general member of an arithmetic progression. The nth term would be put R equal to N. A plus N minus 1 into D would give me the nth term of this arithmetic progression. Clear? Is it confusing? No, no? Now, Suppose I have a set of numbers in arithmetic progression. A is the first term, right? A plus D is the second term. A plus 2D is the third term. A plus n minus 1 into D is the nth term, right? So if you go in this direction, it increases by D, isn't it? From one term to another, it increases by D if you go from left to right. But if you go from right to left, it decreases by D from one term to another. So then, the term prior to this would be D less than this. So the term prior to this, do you realize, is going to be A plus n minus 2 into D is going to be the term prior to this. This minus D. This minus D is A plus n minus 2 into D, yes or no? The term prior to this is going to be D less than this. A plus n minus 3 into D. Yes or no? Yes, now, so this is the first term, second term, third term, fourth term, then this is the nth term, this is the n minus 1th term, this is the n minus 2th term, yes or no? Yes. Are you there with me on this, right? I want to find the sum of n terms of this arithmetic progression. I want to find, this is sum of n terms of the arithmetic progression. Sn is sum of n terms with first term A and common difference D. Now the sum will not get altered if I write the set of numbers in the reverse order. The sum will remain the same, right? So this is like the last term first I write A plus n minus 1 into D. The term prior to that is A plus n minus 2 into D. Then A plus n minus 3 into D. Yes or no? I've just written the terms in reverse order now. Do you see that? The sum will remain the same? Sn, that will be the sum anyways. I'm seeking to find the sum of n terms in terms of A, the first term, and common difference D of this arithmetic progression. Clear? Now, actually this was the first term of the sequence, this is the last term of the sequence. This is the second term of the sequence, this is the second last term of the sequence. This is the third term of the sequence, this is the third last term of the sequence. Yes or no? This is the last term of the sequence, this is the first term of the sequence. Clear? Now if I add these two vertically, 2 times Sn equals, if I add these two, what do I get? 2a plus n minus 1 into D. Then I add these two. 2a plus n minus 1 into D, if I add these two, yes or no? If I add these two, 2a plus n minus 1 into D. If I add these two, 2a plus n minus 1 into d, n minus 3 plus 2 would be n minus 1, yes or no? Two a plus n minus 1 into d. Two a plus n minus 1 into d, yes or no? Hey, do you realize one thing, one property that emerges? One, first term plus last term is the same as second term plus second last term, is the same as third term plus third last term, is the same as fourth term plus fourth last term, yes or no? In an arithmetic progression, sum of terms equidistant from the beginning and end is a constant. See, these are first term and last term equidistant from the beginning and end. Equidistant, these are two terms. This is second term from the first, this is second term from the last. These are equidistant from the beginning and end. This is the third term from the beginning, this is third term from the end. These two are also terms equidistant from the beginning and end. Therefore, in an arithmetic progression, sum of terms equidistant from the beginning and end is the same. You add the first and the last term, or second and the second last term, third and the third last term, fourth and the fourth last term, their sum will be the same. So in an arithmetic progression, sum of terms equidistant from the beginning and end is a constant, which is what you can witness right from here, right? Now, how many such groups are there? N such groups, because first, second, third, nth. So n such groups, each of value 2a plus n minus 1 into d, yes or no? Right? So this is like n times 2a plus n minus 1 into d. Right? Right. So sum of n terms then is going to be, this is 2 times the required sum, Sn plus Sn. Right? So that's going to be n by 2 into 2a plus n minus 1 into d, which is sum of n terms of an arithmetic progression, which is sum of n terms of an arithmetic progression, sum of first n terms of an AP with common, CD is common difference henceforth, common difference D. Is that okay? Now the other thing that you can see very easily is, this can be written as n by 2 into a plus n minus 1 into d. Can I write it like this? Yes, a is the first term, but a plus n minus 1 into d is the last term, yes or no? So this can be written as n by 2 into first term plus last term. Yes or no? Right? So the nth term of the sequence is a plus n minus 1 into d. Sum of the first n terms is n by 2, first term plus last term, or n by 2 into 2a plus n minus 1 into d. Right? Okay. Now, there are host of other things that I'll tell you, but let me also introduce GP. Let me have at least a basic introduction of both these sequences going on today, even before I venture into their properties. Okay. So, a collection of sequence in which any term minus previous term is a constant is a arithmetic progression with a common difference d. Any term is obtained by adding d to the previous term. The nth term of the sequence would be a plus n minus 1 into d. Sum of n terms is going to be n by 2 into 2a plus n minus 1 into d. Now, host of other interesting details about AP, but let me also introduce GP so that you are equipped for the logarithmic sheet at least. Okay. See, a collection of numbers AK, say, a collection of numbers AK of the following kind: A1, A2, A3. This AK is floating. This is a collection of numbers having the property that any term by the previous term, any term divided by previous term is a constant. Any term divided by previous term is a constant. If it has this property, that means the value that A2 by A1 gives, any term by previous term, is the same as the value that A3 by A2 gives, is the same as the value that A4 by A3 gives, is the same as the value that AK by AK minus 1 gives, right? In general, is the same as the value that AN by AN minus 1 gives. This ratio is preserved in this collection of numbers. Any term divided by the previous term is a fixed number, right? That means if A2 by A1 is 3, then A3 by A2 must also be 3. Then A4 by A3 must also be 3, and so on and so forth. If the ratios of consecutive terms is preserved, then the collection of numbers is said to be a geometric progression. Then this collection, this sequence is then referred to as a geometric progression. Is referred to as a geometric progression. So, in general, any term by previous term is a constant. This constant is commonly designated by the symbol R. This constant is designated by the symbol R and is a property of the sequence and is called the common ratio of the sequence. This is called the common ratio of the sequence. This is called the common ratio of the sequence. Which means, if this property is known, that means A2 by A1 will be R, A3 by A2 will be R, A4 by A3 will be R, AK by AK minus 1 will be R, right? This is the common ratio of the sequence. Now, R can be greater than 0, greater than 1. R can be greater than 1. If R is or less than 1, or it could be less than 1. If R is greater than 1, then AK by AK minus 1, any term by previous term will be greater than 1, right? That means AK will be greater than AK minus 1. That means any term will be bigger than the previous term. And then it means the sequence increases. A2 will then be bigger than A1. A3 will then be bigger than A2. A4 then will be bigger than A3, and so on and so forth. It's then an increasing sequence. If the common ratio is greater than 1, it's an increasing sequence. But if R common ratio is greater than 0 and less than 1, then AK by AK minus 1, will be less than 1 and of course greater than 0, right? Yes or no? That means AK will be less than AK minus 1, right? That means any term will be less than the previous term. That means it's a decreasing sequence. A2 then will be less than A1, A3 then will be less than A2, A4 less than A3. It's a decreasing sequence. R can also be less than 0. Not that R can't be 0. R can be less than 0. R equal to 1 will give me AK equal to AK minus 1. That means any term equal to the previous term. That means all terms are identical. So that's only a special case. That's only a special case. I want you to think about what happens when R less than 0 independently. But let me get into some other things first. Right? You understand this description of a geometric progression, right? Now, suppose this A1, which is referred to as the first term. This A1 is referred to as the first term. Let me call it A. Let me call it A. Now in the sequence, AK by AK minus 1 is R. R is a property of the sequence called the common ratio. In this then, AK will be R times AK minus 1. AK will be R times AK minus 1. That means any term can be obtained by multiplying the previous term with R. Any term can be obtained by multiplying the previous term with R, yes or no? Right? That means the second term is obtained by multiplying the first term with R. So the second term would be AR. The third term is obtained by multiplying the second term with R. That means it's going to be AR squared. Yes or no? The fourth term would be AR cubed. Fourth term is 4 minus 1. Third term, this power is 3 minus 1. Second term, the power is 2 minus 1. So in general, the kth term of the sequence, is going to be A into R to power K minus 1. Yes or no? Do you understand that? Do you all understand this? Right? So the kth member of the sequence would be the first member into common ratio to power K minus 1. That will give me the kth term of the sequence. The nth term of the sequence is going to be the first term A into R to power N minus 1. Put K equal to N, you will get the nth member of this collection of terms with common ratio R, first term A. Yes or no? Yes, no confusion about this, right? So now that we know, given the first term A and common ratio R, now that we understand that the collection is a GP series, and we can find any member of this GP series given the first term and common ratio R, it then becomes binding upon us to be able to evaluate the sum of n terms of this GP series given the first term A and the common ratio R. I want to be able to compactly represent sum of first n terms of this GP series. How about it? Right? So what we do is the following. Say I have a GP series and sum of n terms. What's the first term? A, say. R is the common ratio of this GP series. I hope everyone in the class is registering everything. I do not know if I'm going too fast or too slow for you. Are you in sync with me on everything that I'm saying? If you want me to be slow, I can be slower. If you want me to maintain the speed, I'll maintain the speed. Are you all comfortable with this? Right? Sum of n terms. First term A. Right? What would be the second term? AR. What would be the third term? AR squared. Cube. Now, the nth term is going to be to power n minus 1. That's going to be the nth term. Now, if I go in this direction, I multiply by r. But if I go in this direction, I divide by r. That means the term prior to this is obtained by dividing by r. So it's going to be ar to power n minus 2. The term prior to this is going to be yes or no? Now, what I do is, I multiply throughout by r. My objective is to obtain Sn in a compact manner. Sum of n terms of a GP series in a compact manner is what I am seeking to do here. Right? R times Sn. R times Sn means this will become AR. I write it below this because AR with AR, right? Apples for apples. So this will become AR if I multiply with this, and instead of writing AR below this, I write AR below this. When I multiply this with R, what will it become? AR squared, and I write it below this, right? When I multiply this with R, what do I get? AR cubed, I write it below this. That means I multiply by R and shift the whole thing 1 unit to the right. I multiply the whole thing by R and shift by 1 unit to the right. Yes or no? So then, this when multiplied with R will give me AR to power n minus 2 and will appear here. And will appear here. This when multiplied with R will give me AR to power n minus 1 and will appear here. And this when multiplied with R will give me AR to power n and will appear here. Yes or no? Do you all understand this? Now I subtract this minus this. I get 1 minus R Sn equals, do you realize this will get cancelled with this? This will get cancelled with this. This with this. This with this. This with this. There is only one unattended virgin term here, which is AR to power n. Right? And A. So then I end up getting A minus AR to power n. I'm subtracting, right? A minus AR to power n. Yes or no? This gives me Sn, sum of n terms, as A into 1 minus common ratio to power n divided by 1 minus R. First term, R is the common ratio, n is the number of terms. This will give me sum of n terms of a GP series. Sum of n terms of a GP series with first term A, common ratio R, number of terms n. Sounds good? Now, can I wipe this off? See, if I take 3 consecutive members of a GP series, any 3 consecutive members, AK minus 1, AK and AK plus 1. These are 3 consecutive members of the GP series, right? Then I end up getting AK divided by AK minus 1 equals AK plus 1 divided by AK. Yes or no? Any term divided by previous term is the same. So this divided by this must be the same as this divided by this. Clear? Right? Which means this is the middle term. This is the middle term. This gives me AK squared equals AK minus 1 into AK plus 1. Yes or no? AK minus 1 into AK plus 1 is what I get out of this. Which means if I take any 3 consecutive members of a GP series, then square of the middle term will be product of the two adjoining terms. Square of the middle term will be product of the two adjoining terms. That means if A, B, C are three consecutive members of a GP series, then we must have B squared equal to AC. We must have B squared equal to AC. Then if this happens, AK is root AK minus 1 into AK plus 1, and we learned that this is the geometric mean of these two terms. This is actually called the geometric mean of AK minus 1 and AK plus 1. Geometric mean of AK minus 1 and AK plus 1. See, that's one of the possibilities. I'm saying this is one possibility. One of the possibilities is that B could be the geometric mean of A and C. Right? So, if A, B, C are in GP, then B squared must be AC. Right? So, I've just given you a bare skeletal form of this progressions AP, GP. The nth term of an AP, what an AP means, what the common difference is, a property which is like any term minus previous term is a constant, another property, sum of two terms equidistant from the beginning and end equal to a constant. That's true in an AP. In a GP, common ratio is a property, any term by previous term is equal to the common ratio, right? Common ratio greater than 1, it's going to be an increasing GP. Common ratio lying between 0 and 1, it's going to be a decreasing GP, right? If you take three consecutive members A, B, C of a GP series, then square of the middle term would be the product of the two neighboring terms. The other fact that you would see very easily is that you might want to see it yourself. Product of terms. See, for example, A1 is A. AN would be AR to power n minus 1? Yes or no? The nth term? Okay. The term prior to this, AN minus 1, can be obtained by dividing this by R. So this term is going to be what? AR to power n minus 2. This term is going to be AR. Yes or no? Now, what is A1 into AN? First term into last term. A1 into AN. A squared R to power n minus 1. What is A2 into AN minus 1? Check all this. In an AP, sum of terms equidistant from the beginning and end is a constant. In a GP, product of terms equidistant from the beginning and end is a constant. Do you realize it's the same value? First term into last term is this value. Second term into second last term is the same value. Third term into third last term is the same value. So in a GP series, product of terms equidistant from the beginning and end is a constant. In an AP, sum of terms equidistant from the beginning and end is a constant. In a GP, product of terms equidistant from the beginning and end will be a constant. For day 1 on progressions, I have just about equipped you with skeletal understanding so that you know if there is this terminology AP-GP appearing in a trigo sheet or in a logarithmic sheet or in a quadratic sheet, you don't feel lost. Right? To that extent, I have just about given you a bare minimum threshold understanding of AP and GP. Right? But there are more facts about it, all related to this, nothing difficult, but we'll learn them maybe tomorrow. So